Hey everyone, Linus here. Today we're diving into the fascinating world of instruction set architecture, or ISA for short. If you've ever wondered how your computer understands and executes commands, then you're in the right place. Think of ISA as the language your computer's brain, the CPU, understands. Just like we use languages to communicate with each other, CPUs use ISAs to process instructions. It's a crucial part of how computers function. Imagine trying to give someone directions in a language they don't understand. It would be chaos, right? The same goes for computers. Without a clear set of instructions or an ISA, the CPU wouldn't know what to do. Just like we use English to communicate, CPUs rely on ISAs to process instructions. These instructions are like commands that tell the CPU what to do, such as adding numbers, moving data, or displaying something on your screen. Each instruction in an ISA has a specific code that the CPU recognizes and executes. It's like a secret codebook that only the CPU and the software running on your computer know. This codebook is essential for the smooth operation of your computer. Without an ISA, your computer would be a useless hunk of metal and silicon. The ISA is what breathes life into the hardware, allowing it to perform complex tasks and run various applications. ISAs are the fundamental building blocks of computing. They enable everything from simple calculations to advanced machine learning algorithms. In essence, they are the backbone of all modern technology. So next time you use your computer, remember the invisible language working behind the scenes. It's the ISA that makes it all possible, transforming raw data into meaningful actions. Understanding ISAs gives us a deeper appreciation of the technology we often take for granted. They are the unsung heroes of the digital age, making our lives easier and more connected. Now let's talk about the relationship between ISA and the CPU. The CPU is like the engine of your computer and the ISA is the mechanic's manual. The ISA tells the CPU how to interpret and execute instructions. It defines things like the size of data the CPU can handle, the types of operations it can perform, and the way memory is organized. Different CPUs can have different ISAs, just like different car engines have different designs. Some ISAs are designed for speed, some for efficiency, and others for specific tasks like graphics processing. For example, Intel's x86 ISA is known for its compatibility and performance, while ARM's ISA is popular in mobile devices due to its energy efficiency. Let's look at some real-world examples to make this clearer. One of the most common ISAs is x86, used in most desktop and laptop computers. Another popular ISA is ARM, which powers billions of smartphones, tablets, and other mobile devices. You'll also find ISAs in gaming consoles, smart TVs, and even your car's entertainment system. Each of these devices uses a specific ISA that best suits its needs and requirements. For instance, a gaming console needs a powerful ISA to handle complex graphics and physics calculations, while a smartwatch prioritizes a low-power ISA to extend battery life. Understanding the different types of ISAs helps you appreciate the diversity and complexity of the computing world. Now, how does ISA affect the software you use every day? This is a crucial question because the ISA, or instruction set architecture, serves as the bridge between software and hardware. It dictates how software communicates with the CPU, which is the brain of your computer. Well, software developers write programs using programming languages like C++ or Python. These high-level languages are user-friendly and allow developers to write complex programs without worrying about the underlying hardware. These high-level languages are then translated into machine code, which is a series of instructions that a specific ISA can understand. This translation process is known as compilation, and it's essential for the software to run on any hardware. This means that software written for one ISA won't necessarily work on a system with a different ISA. Compatibility issues can arise, leading to software errors or even complete failure to run. Think of it like trying to read a book written in a language you don't understand. Just as you need a translator to read that book, software needs the correct ISA to communicate with the CPU. The ISA acts as a translator between the software and the CPU, ensuring they can communicate effectively. Without this translation, the CPU wouldn't know how to execute the software's instructions. The choice of ISA also impacts performance. Different ISAs can optimize for different types of tasks, affecting how quickly and efficiently your computer can run software. Some ISAs are designed for complex instructions, which can be more efficient but require more powerful CPUs. These complex instruction set computers, CISC, can handle intricate tasks with fewer lines of code. Others use simpler instructions, making them easier to decode and execute but potentially requiring more instructions to perform the same task. These reduced instruction set computers, RISC, are designed for speed and efficiency, often used in devices where power consumption is a concern. Ultimately, the ISA you choose can influence everything from the type of software you can run to the overall performance and efficiency of your system. Whether it's a desktop, a smartphone, or a server, the ISA plays a pivotal role in shaping your computing experience. Section 5. Why different ISAs exist. A historical perspective. Why are there so many different ISAs, you ask? Well, it's a bit of a history lesson. In the early days of computing, resources were limited, and every byte of memory counted. ISAs were designed to be simple and efficient, with a focus on minimizing the number of transistors required to build a CPU. As technology advanced, CPUs became more powerful, and ISAs evolved to take advantage of these advancements. Some designers focused on creating ISAs with complex instructions, while others stuck with simpler designs. This led to the emergence of two dominant ISA philosophies: complex instruction set computing, or CISC, and reduced instruction set computing, or RISC. Section 6. RISC versus CISC, a tale of two architectures. CISC, as the name suggests, uses a large set of complex instructions, aiming to accomplish more with each instruction. Think of it like having a Swiss Army knife of instructions. RISC, on the other hand, uses a smaller set of simpler instructions, focusing on speed and efficiency. It's more like having a dedicated tool for each task. Both approaches have their pros and cons. CISC can be more efficient for certain tasks, but requires more complex CPUs. RISC is generally faster and more energy efficient, but might require more instructions for complex operations. Section 7. The evolution of ISAs, from simple to complex. Over time, ISAs have become more sophisticated, incorporating features like pipelining, superscalar execution, and out-of-order execution to boost performance. These advancements allow CPUs to process multiple instructions simultaneously, making them significantly faster than their predecessors. We've also seen the rise of specialized ISAs designed for specific tasks, such as graphics processing, artificial intelligence, and machine learning. These specialized ISAs are optimized for their intended workloads, delivering significant performance gains. The evolution of ISAs is a testament to the ingenuity of computer scientists and engineers who constantly push the boundaries of computing. Section 8. The future of ISA trends and predictions. So, what does the future hold for ISAs? One trend is the increasing importance of energy efficiency, especially in mobile and embedded devices. We're likely to see ISAs that are specifically designed for low-power operation, enabling devices to run longer on a single charge. Another trend is the growing role of specialization. As artificial intelligence, machine learning, and other specialized workloads become more prevalent, we can expect to see more ISAs tailored to these specific tasks. Finally, quantum computing, with its entirely different approach to computation, could lead to the development of entirely new types of ISAs, revolutionizing the way we think about computing. Section 9. Conclusion. ISA, the unsung hero of computing. ISA might be a behind-the-scenes player in the world of computing, but it's a critical component that underpins everything your computer does. The instruction set architecture, or ISA, is essentially the blueprint that defines how a computer's processor understands and executes instructions. Without it, the seamless operation of software and hardware would be impossible. It's the bridge that connects the high-level software we interact with daily to the low-level hardware that performs the actual computations. Understanding ISA gives you a deeper appreciation for the complexity and ingenuity of computer systems. It's like learning the language that computers speak. By delving into ISA, you uncover the intricate dance of commands and operations that power everything from simple calculations to complex algorithms. This knowledge not only enhances your technical skills but also provides a solid foundation for innovation in computing. From the simplest smartphone to the most powerful supercomputer, ISA plays a vital role in shaping the digital world around us. Every device, whether it's your everyday smartphone or a cutting-edge supercomputer, relies on ISA to function efficiently. It dictates how data is processed, how instructions are executed, and ultimately, how we experience technology in our daily lives. So the next time you're browsing the web, playing a game, or watching a video, take a moment to appreciate the unsung hero of computing the instruction set architecture. It's the invisible force that ensures your applications run smoothly, your games are immersive, and your videos stream without a hitch. Without ISA, the digital experiences we often take for granted would be far less reliable and efficient. It's the silent conductor orchestrating the symphony of bits and bytes that make up our digital lives. Every keystroke, every click, every digital interaction is meticulously managed by the ISA, ensuring harmony and precision in the digital realm. It's a testament to the brilliance of computer engineering and the unsung heroics of the ISA. Catch you in the next one.